Good evening, children.
Good evening, ma'am.
Good evening. Have you all completed this, children, in your notebook?
Yes, ma'am.
Very good. All right. Okay. So this is the next one. Kamala has a triangular field, okay, with sides 240 meters. As we read, the figure is given to you. As we read, let's see the information in the figure also represented in the figure. So Kamala has a triangular field with sides 240 meters. Okay, so we can see it here, 240 meters. 200 meters, 200, okay, 200 meters and 360 meters. Okay, so they're talking about this triangle. Okay, so Kamala has a triangular field with sides 240 meters, 360 meters and 200 meters here, where she grew wheat. So in this portion, in this triangular portion of the field, she grows wheat. In another triangular field, with sides 240 meters. So see here, the same thing, 240 meters, 320 meters, and 400 meters, adjacent to the previous field. So just next to the previous field. So you can see the two fields are, connected. They're not in two separate places. They're next to one another. So adjacent. Okay. So in another triangular field with sides 240, I showed you here 240, 320 and 400 meters adjacent to the previous field. So this is the second field. This is the first field. So the second field is adjacent to the first field. See, we are talking about this full triangular portion, Okay, so there is one like this, the first triangular portion like this, the other one like this, the other one something like this. Okay, so we have not still discussed about this one in the middle. We have still not discussed about this line or line segment which runs in the middle of this triangle. We haven't still spoken about that. So just look out for these two triangles. So this is the first field where she grows wheat, and adjacent to this one there is another triangular field, so something like this. Okay, and here you can see a line segment running between the triangle. We'll talk about that later. Okay, so she wanted to, so in this adjacent field, she wanted to grow potatoes and onions as shown in the figure. She wants to grow potatoes and onions as shown in the figure. She divided the field. So now you can see she divided the field into two parts. Okay, by joining the midpoint of the longest side to the opposite vertex, and grew potatoes in one part and onions in the other part. 1 minute, children. I need to turn off the stove. I'm just coming. Yeah, so what she does, she takes the midpoint of the longest side. So this is the second field with sides 240 meters, 320 meters and 400 meters. So we can see that 400 is the longest side, or this is the longest side. This one is the longest side. So she takes the midpoint of the longest side. So this is the longest side of the second triangle. She marks off the midpoint of the longest side, 400. So this is 200 here. Okay, and from there what she does, she joins this midpoint, she connects it to the opposite vertex. So she goes like this. All right, that's how we get the line segment CE. That's how we get the line segment CE. So CE is a line segment connecting the midpoint of AD, midpoint of the longest side of the second triangle. Okay, E is the midpoint. E is the midpoint of AD. AD is the longest side of the second triangle. and E is connected to the opposite vertex C. Now, what you need to understand is CE is the median. CE is the median of the triangle ACD on the side AD. Now, what is a median? A median is a line segment from the vertex to the midpoint of the opposite side. Okay, so in a triangle, now we'll take the same measurement 400. So the midpoint here. Okay, so it's 200 here and 200 here. When I connect it like this, when I connect the midpoint to the opposite vertex, now this line segment is called the median. And what is the property of the median? The median divides a triangle into two triangles equivalent area. The two triangles need not be congruent, meaning they need not be identical. Congruency meaning identical. Just like, the two things are just like one another. No. So the median divides the triangle into two triangles equal in area. The two triangles need not be congruent. They may be. Okay, in the case of some triangles like equilateral and some triangles and isosceles, they may be congruent and equal in area. But in general, the property of the median is that it divides the triangle into two triangles equal in area. The two pieces need not be congruent to each other. All right, so now the whole triangle, let me just call it ABC. The whole triangle ABC is divided into two triangles, ABD and ACD. Why? Because AD is the median. Why do we call AD the median? Because D is the midpoint of BC. How do we know that D is the midpoint of BC? Because it's given. That's how she connects. She marks off the midpoint. Okay, so D is the midpoint of BC and she connects D to A, the opposite vertex. Okay, I've taken different letters. I'm sure you can relate it to the original figure. So she connects D to A. That way she's taken the median of the triangle ABC. See, children, I'm not, see, please understand, I'm talking about this triangle. I've marked ABCD, but please relate this idea to this triangle. Am I clear?
Yes, ma'am.
All right. So AD is the median. Okay. Why is it the median? Because it's a line segment from the vertex to the midpoint of the opposite side. So it's a median. What is the property of the median? The area of this triangle is equal to the area of this triangle. So area of triangle ABD is equal to area of triangle ACD. Are these two triangles congruent? Need not be. Need not be. But they're definitely equal in area. That is the property of a median in a triangle. So what she's done is, so she's a very smart farmer, Kamala. So what she does, she wants to grow potatoes and onions in equal portions. She wants to grow potatoes and onions in equal portions. So whatever is the total area of the field, supposing the total area of the field is say 1,000 meters square, she wants to grow potatoes in 500 meters square and onions in the remaining 500 meters square. All right. All right. Okay. So these two triangles are equal in area. So the area in which she grows potatoes is equal to the area in which she grows onions. That's because of the property of the median CE. Okay, let's read further. How much area in hectares? So again, what is this hectare? Hectare is a unit for area. So when the land is now agricultural land, they're really huge, they're big. You cannot, so that's not measured in meters square because it's really huge. So hectare is a larger unit for measuring area. Hectare is not a unit of length. You cannot say the length of the field is 1 hectare. Hectare is not a unit for length. Okay. Hectare is not a unit for length. You cannot say that the length of the field is 1 hectare, the breadth of the field is 2 hectares. No, because length and breadth are one dimensional. Length, breadth, height, they are one dimensional. Hectare is not a unit for measuring length, breadth, or height. Hectare is not one dimensional like centimeter, meter, kilometer. Okay, so you can say the length is 1 kilometer, 2 kilometers, 3 kilometers. No, hectare is a unit for measuring area. An area of 1 hectare is equal to 10,000 meters square. An area of 1 hectare. If a farmer tells you that he has 1 hectare of land, that means he has a land which measures 10,000 meters square. 10,000 meters square. You can imagine how much 10,000 meters square is. So you know the area of your house, right? The area of your house you live in. Okay, so supposing on an average, we live in a house which has a floor area of 1,000 meters square, just for example. Okay, so it could be 600, 700, 1,000, 2,000. So whatever is the area of the house you live in. All right, so supposing the floor area, I'll just take an average 1,000 meters square. If the floor area of the house you live in is 1,000 meters square, 10 times that is an area of 10,000 meters square. So you can check with your parents, the floor area of your house, or if you know it, fine. And see how many times that area. Or if you're living in a house whose area is 10,000 meters square, that is the area of the agricultural field. I don't know. So it's like that. So say so I was telling you 1,000 meters square, right? So 1,000 meters square into 10,000 meters square, that big field it is. That area is equal to 1 hectare. 1 hectare is equal to an area of 10,000 meters square. 10,000 meters square. All right, let's see the question again. Let's see the question again. So Kamala has a field, a triangular field. Kamala is a farmer. She has a triangular field. She has this triangular field ABC. ABC. You can see the sides of the field: 360, 240, and 200. Adjacent to this field ABC, she has another field ACD. She has another field ACD. Two sides are 240 meters, 400 meters, and 320 meters. Now she wants to grow 3 crops, but she has only 2 triangular portions. But she wants to grow 3 crops. And on one, she's decided she's going to grow wheat. On this triangular portion, okay, she's decided to grow wheats. She's decided to grow wheat. Now she has to grow the remaining 2 crops, potatoes and onions. She has only 1 triangular field. And she wants to grow these 2 crops in equal areas. So what she does, she takes the longest side. Okay, she takes the longest side, 400. She marks off the midpoint, 200. She connects that to the opposite vertex C, and that's how she gets the line segment CE, or the median CE. Now she knows that she's divided the field into 2 parts equal in area. So now Kamala knows that she's divided the field into 2 parts equal in area, because CE is the median. And she grows potatoes in one part and onions in the other part. Is the question clear, children?
Yes, ma'am.
All right. All right. Yeah. So that's the question. Now, I also told you that an area of 1 hectare is equal to 10,000 meters square. Now, the rest of it is very simple. So you know how to compute area. Now, what's the question? How much area? You need to find the area in hectares. How much area in hectares has been used for wheat, potatoes, and onions? That's the question. So you should find the area of the field in which she grows wheat, area of the field in which she grows potatoes and onions separately. The 3 separately you'll have to find. Okay, so like I'm not explaining, you should understand this. So semi-perimeter and all that. The area of this field is 16,000 root 2. See, I'm talking about the first field ABC. Okay, ABC. Okay. Now area of the triangle ABC is 16,000 root 2. With the value of root 2 is 1.414. So 16,000 into 1.414, which is 22,624 meters square. This is the area of the field in which she grows wheat in meters square. But you will have to find it in hectares. Okay, the short for hectares is HA. Like kilometer, you say km, right? Kilometers, km, meters, centimeter, decameter, decimeter, hectometer. So like that, hectare, HA.
Excuse me, ma'am.
Yes?
Ma'am, can we take 1.414 as an estimate value, like 1.4?
And no, actually that information will be given in the question. Take root 2 as whatever. But if nothing is given, we mostly take up to 3 decimal places.
Okay, ma'am.
Now, like for root 3, we say 1.732. if nothing is mentioned, but you have to use the decimal value, say nothing is mentioned, but you have to use the decimal value for further calculation, then you have to take 1.732. But in most cases, it will be given in the question. The values of root 2, root 3, whatever will be given in the question. But if nothing is given, I would suggest take 1.732 and 1.414 accordingly.
Okay, ma'am.
Yeah. All right. Or see again, when if your teacher is insisted on a particular value, please go with your teacher. Please go with your school teacher if she's given you any specific information.
Yes, ma'am.
Yeah. But what I'm saying is not incorrect. Okay. If I don't know something, I'll say I don't know. So what I say is not incorrect. We normally take up to 3 decimal places. Okay. Yeah. So 16,000 into, yeah, 16,000 into 1.414, which is 22,624 meters square. Now, how do you convert? So we know that an area of, see, this is supposing you don't know if you should multiply or divide. You don't know, supposing we have a doubt in the exam, we are tensed and, we multiply instead of dividing. So you can always use this, children. See here, hectare is to meter square is as to hectare is to meter square. You might think it's so tedious, but just, understand so that you don't go wrong. Okay, you can also write meter square is to hectares is as to meter square is to hectares, or even simpler, I can tell you like this, 1 minute, even simpler. Like you can write it like this here. 1 hectare is equal to 10,000 meters square. All right, 10,000 meters square. Then 22,000, what was that? 22,624. Then 22,624 meters square is how many hectares? X meter square. Oh, sorry, X hectare. I'll just rewrite the same thing, children. Same thing, I'll just rewrite. 1 hectare is 10,000 meters square. How many hectares is 22,624 meters square? You can write it like this, or you can write 10,000 meters square is 1 hectare. Then 22,624 meters square is how many hectares? Again, I went wrong writing. Now you just have to cross multiply. Just cross multiply. You're trying to find the value of x. Just cross multiply. So x into 10,000. You can do this in your mind. You don't have to show so many steps. X into 10,000 is equal to 1 into 22. Okay. X into 10,000. When you cross multiply, x into 10,000 is equal to 1 into 22,624. So x is equal to, so you have to divide 22,624 divided by 10,000. So which is, 2.2624 meters square. The same thing you will get here. Here also cross multiply and get it, you will get the same thing. Isn't this easy, children?
It's easy, ma'am.
Yeah, so you should not say, like instead of multiplying, I divided, or instead of dividing, I multiplied. No excuses like that. Should be very clear with all this. So you can use this, method. Just write the standard conversion like this. The standard conversion, 1 hectare is 10,000 meters square. You can also write 10,000 meters square is 1 hectare like this. Anyways, but you should match. The numerator must have hectares. The denominators must have meter square, or the numerators must have meter square and the denominators must have hectares. If you interchange something, it's wrong. You cannot write it however we want. Should follow this. Numerators and denominators must have the same unit. Clear, children?
Yes, ma'am.
Yeah. So to convert here, we have to divide by 10,000, or you can do this in the rough work. You can do this in the rough work. So here we have to divide. To convert hectare to meter square, we'll have to divide by 10,000. Okay, just in case you want to make a note of this, you can take a screenshot or whatever. I'll not give you time to write in the class, children, because I want you to focus on the calculations and do it. So you will be, I'll explain the whole thing. You will have to take screenshots and complete it later and share the pictures with me. All right?
Yes, ma'am.
Yeah.
Yes.
All right. Yeah, children. Yeah. Okay, so that's what it is. So see here, then I've converted it to hectares, converted meter square to hectares like this, meter square to hectares like this by dividing by 10,000. So many hectares, or yeah. So the area of the field used for growing wheat is equal to 2.26 hectares. I told you HA is the short for writing hectares. Similarly, find the area of the other triangle. Now you don't have to, you cannot find the area of this triangle separately and this triangle separately because you do not know this side, CE, you do not know. You cannot find the areas of this triangle and this triangle separately because you do not know the length of the line segment CE. You know this is 200, this is 200, but you need to know all the three sides of the triangle in order to use Heron's formula. But we do not know the length of CE, so you cannot find the areas of these two triangles separately. So you have to find the area of the whole triangle ACD, and divide by 2 because of the property of the median. Divide by 2. All right, so find the area of the triangle ACD. So see here, using Heron's formula, found the area of the triangle ACD, 38,400 meters square. Divide by 10,000 to convert it to hectares because we are asked to find the area in hectares. Find the area in hectares. So divide by 10,000. So it's 3.84 hectares. So in triangle, see here, in triangle ACD, please see the figure in triangle ACD. What is CE? CE is the median. CE is the median. So area of triangle ACE is equal to the area of triangle CED. So like this, you understand, 1.92 hectares. So potatoes are grown in 1.92 hectares and onions in 1.92 hectares. Clear, children?
Yes, ma'am.
Ma'am.
Yeah, children.
Yes,
Please take a, yes, very good. Please take a screenshot, children. Good.
Taken, ma'am.
Very good. So you can see here, children, that I got 440, 200, and 160. What I did, I've had this 200 as it is, and I wrote 400 as 200 into 2. And this 40 I've written as it is. And I wrote 160 as 40 into 4. So like this, we have two 200s, two 40s. I've written this 200 as it is. This 40 as it is. 400 is 200 into 2. 160 is 40 into 4. You should understand why we are writing like that. Now there are two 40s. So 140 comes out. Two 200s. One 200 comes out. Then there is 4. No, there is 4. So it will come out as 2. Square root of 4. So it comes out as 2. This one comes out as 2. And there's only 2 under the square root. So root 2. And here, see here, I've written 240 as it is. This 240 I've written as it is. And this 80 as it is. 80 as it is. Now I've written 160 as 80 into 2. And 480 as 240 into 2. So from two 240s, one 240 out. From two 80s, 180 out of the square root. And from two 2s, 1 2 out. If this is not comfortable, you can use your convenient method. If you want to break down 400 complete, 480 completely, to 240 times, to 120 times, that's going to take a long time. But, don't go wrong. That's all. So you can use this method. You just have to find, you must have equal factors, pairs of equal factors. They need not be prime. Just two equal factors you need to have, 240, 240, 160, 160, sorry, 80, 80, 2, 2. That's it, to get rid of the square root symbol. All right, children?
Yes, ma'am.
Yeah, fine, yeah. Now look at this question. So, yeah, two parallel sides of a trapezium are 60 centimeters and 77 centimeters. And the other sides are 25 centimeters and 26 centimeters. Find the area of the trapezium. Now, the formula to find the area of a trapezium, listen carefully. A class, use the emoji, raise your hand. Very good. Krishmika, Netra, Madhumita, Danya, Raja, and Tanishka. Raja, so you were late in joining the meeting?
Yes, ma'am, by 10 minutes.
So do you have the time to watch the recordings for the 10 minutes you have missed?
Yes, ma'am. Surely I'll watch it.
Okay. Okay, fine. All right, children. So, yeah. Now, the question is very simple. When you read the latter part of the question, find the area of the trapezium. What is this? Find the area of the trapezium in ninth standard. We've already, done all this in seventh and eighth itself. Okay. So what is new? What is new here? Why area of trapezium again? We have done lots of this in our lower classes. Why area of the trapezium again? So here you can see that, in the trapezium, we're given the parallel sides are 60 and 77, 60 and 77. See, according to the figure, you'll have to mark it. Now, these are the parallel sides, and one is 60, the other is 77. So the longer side is 77. All right. The longer side is 77. So by this figure, DC is 77 and AB 60. The other sides are 25 and 26. So 25, 26, anywhere you can mark. You can write 25 here and 26 here, or 25 here and 26 here. That's not going to alter or affect your answer, the final answer. Okay. That's not going to affect your final answer. All of us will get the same answer. Okay, so I'll take, somehow I feel this is longer, so I'll take 25 here and 26 here because I feel this side is longer. So like this. Now what you see is the formula to find the area of a trapezium is half sum of the parallel sides into distance between them. Just a second. Yep. All right, children. So the formula to find the area of a trapezium is equal to half sum of the parallel sides, half into sum of the parallel sides, AB plus CD, into the distance between them, which we do not know. We don't know the distance between the parallel sides. See, 25 is not the distance between the parallel sides. 26 is not the distance between the parallel sides. Distance between the parallel sides is the perpendicular distance between the parallel sides. Distance between the parallel sides is the perpendicular distance between the parallel sides. So we do not know the perpendicular distance between the two parallel sides AB and CD. So we need to find that and then use the formula. Got it, children?
Yes, ma'am.
Yes, ma'am.
Yes.
Very good. All right. So for that, the construction is draw BE. Okay, so draw BE. Let me draw it more neatly. So 60, 77, 25, 26. As I told you, we do not know the distance between the parallel sides. So construction, draw, you can mark this E. Draw BE perpendicular to DC. Why? Because BE now represents the distance between the parallel sides AB and CD. The perpendicular distance between the parallel sides AB and CD. Okay, so now we'll have to find BE. All right. Now, there's another thing you'll have to do. You'll have to now you'll have to actually divide this, a trapezium into two figures, one parallelogram and one, what do you say? Sorry, the messages are distracting me, children. I'll just reply and get back. Sorry. Yeah, thank you. So yeah, so BE represents the distance between the parallel sides AB and CD. Now we need to divide this trapezium into two plane figures, one parallelogram and another triangle. All right. So now what we do through B, we draw a line parallel to AD. Now see here. So through B, I draw a line parallel to AD to meet DC at F. To meet DC at F. So two things you have to do. One obvious thing is you do not know the distance between the parallel sides. You do not know the distance between the parallel sides, so you'll have to drop BE, the perpendicular, from B on DC. That is the first thing. Okay, that is one thing. That need not be the first thing. That's one thing. Then the other thing is that the idea is we have to divide the trapezium into two plane figures, one parallelogram and another triangle. For that, what we do is through B, we draw a line parallel to AD, parallel to AD, see here, parallel to AD to meet DC at F. Through B, draw a line parallel to AD to meet DC at F. Somebody repeat that. Repeat the construction. Raja, tell me the constructions. How will you explain BE?
Ma'am?
Explain BE.
Ma'am,
Yeah, I can hear you. Tell me.
ma'am, we have to draw a perpendicular to
Yeah, very good. Yes. We have to drop a perpendicular from where? From
DC.
B on
B. On
oh,
DC.
from on DC. Very good, very good. We have to drop a perpendicular from B on DC. Very good. And what do you say about BF? BF is parallel to which side of the trapezium? BF is parallel to which side of the trapezium?
Ma'am, ma'am, ma'am,
Yes, I'm right here.
AD, ma'am.
This AD. BF is parallel to AD. BF is parallel to AD. Where does that line which is parallel to AD meet DC? That line through B, which is parallel to AD, where does it meet DC?
F, ma'am.
F. It meets DC at F. Okay. All right. Just a minute. Okay. So now we have two plane figures ABFD, which is a parallelogram. I'll explain why it's a parallelogram, and parallelogram ABFD and triangle BCF. Okay. Now, how can we say that ABFD is a parallelogram? Because in a trapezium, already opposite sides are parallel. So as it is, we have AB parallel to DC. Because ABCD is a trapezium, we already have AB parallel to DC, which means AB is parallel to DF also. ABCD is a trapezium with AB parallel to CD. So AB is already parallel to CD. That means AB is parallel to DF. AB is parallel to DF. And by construction, we have BF parallel to AD. So what do you understand from these two? In the quadrilateral AB FD. I'm pausing so that you look at the figure. In the quadrilateral ABFD, AB is parallel to DF BF is parallel to AD by construction. So in a quadrilateral, when both the pairs of opposite sides are parallel, it is a parallelogram. It is a parallelogram. Therefore, ABFD is a parallelogram and BFC is a triangle. BFC is a triangle. So now we have divided the trapezium into a parallelogram and a triangle. So the area of the trapezium can be found in two ways. The area of the trapezium can be found in two ways. You can find the area of the parallelogram, find the area of the triangle and add both. Or you can directly find the area of the trapezium using the formula. So two ways you have to find the area of the trapezium. You can find the area of the parallelogram, find the area of the triangle and add the areas to find the area of the trapezium. Or you can directly use the formula to find the area of a trapezium and find its area. So we have to find BE. Now we have to find BE. What you need to understand is BE is the height of the parallelogram and also the height of the triangle. See, what's the formula to find the area of a parallelogram? What is the form?
Half into
Base into height. Who said B into H first? Very good. Who said B into H?
Tanishka.
Very good. Very good. The formula to find the area for okay, all of us know it. Tanishka was the first to say. So the formula to find the area for parallelogram is base into height. Okay, so we know the base. We'll see what the value of the base is. We know the base, but we do not know the height. B is the height of the parallelogram. It lies outside the parallelogram. B is the height of the parallelogram. It lies outside the parallelogram. That's all. This is the height of the parallelogram. It lies outside it. Height is the distance between the parallel sides. Height is the distance between the parallel sides. So see, from here to here, the perpendicular height, it lies outside the figure, that's all. And B is also the height of the triangle. So B is the height of the parallelogram as well as the height of the triangle. So you need to find B. So, okay, let me put it like this. BE is the height of the parallelogram. BE is the height of the triangle. BE is also the distance between the parallel sides of the trapezium. So many roles BE plays. BE has three roles. Like a person can be somebody's, somebody's sister, mom, friend, auntie. So one person can have so many roles, right? So like that, now you, for example, so you are somebody's daughter, somebody's sister or brother. No, okay, sister or brother, somebody's cousin. So you have so many roles. You have, so many titles. So like that here, BE, the line segment BE is the height of the parallelogram ABFD, is the height of the triangle BFC, is also the distance between the parallel sides of the trapezium ABCD. Clear so far, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now again, the property of a parallelogram. Opposite sides are equal. Like in a rectangle, in a parallelogram, opposite sides are equal. So if AB is 60 centimeters, how much is DF?
60, ma'am.
60. Because in the parallelogram, opposite sides are equal. So if AB is 60 centimeters, the opposite side of the parallelogram, DF, is also 60 centimeters. Now, what is the full thing from here to here? 77. 77. So the remaining portion from F to C, the remaining portion is 17. Of course, it's not proportional. You will ask me 60 is so small, but 17 is so big. It's just a representation, no? So I cannot be accurate. So yeah, FC, the remaining portion is 17. Understood? The whole thing, DC, from D to C is 77. From D to C is 77. That's given in the question. Now DF, D to F is 60 because the opposite sides of the parallelogram are equal. So the remaining part is 77 minus 60, which is 70. Okay. So now again, AD is equal to BF. This is F, children. This is F. Okay, AD is equal to BF. This is also 25. This is also 25 because in a parallelogram, opposite sides are equal. AD is equal to BF. Opposite sides are equal. So like this, we have found all the three sides of the triangle BFC. What's the length of BF, children? In triangle BCF, how much is BF?
25, ma'am. 25, ma'am.
How much is the FC?
17, ma'am.
And how much is BC?
26. 26, ma'am.
26. Can you find the area of the triangle using Heron's formula?
Yes, ma'am.
Yes, ma'am.
Oh, okay. Now, once you find the area of the triangle using Heron's formula, see here. I found the area of the triangle using Heron's formula. I found the area of the triangle using Heron's formula and I got 204. The area of this triangle, the area of this triangle is 204 centimeters square. But you know that you can also find the area of the triangle using the formula half base into height. So area of the triangle is 204, half into base EB into height CM is equal to 204. Understand? Half into base. See, area of the triangle we found using Heron's formula is 204. But area of the triangle can also be found using the formula half base into height. So half into base EB into height CM is equal to 204. Half into EB 17. EB 17. Height CM we don't know. The altitude we do not know is equal to 204. So with this you can find CM. You can work this and find CM. Now I told you can find the area of the trapezium in two ways, like this or like this. Okay, so what's the area of the parallelogram ADCE? What's the area of the parallelogram ADCE? Base into height. Base is AE. Base is AE and height is CM. AE. Base is AE, children. Base of the parallelogram, not the base of the trapezium. Area of the parallelogram. So base of the parallelogram AE 60 into the height. See here, height 24. So you get 1440. Okay. And the area of the trapezium will be, the area of the trapezium ABCD will be area of the, see I've marked it 1 and 2. I've marked the area of the triangle 1. I've marked the area of the triangle as 1 and the area of the parallelogram as 2. So the area of the trapezium is 1 plus 2. So 204 plus 1440, which is 1644 centimeters square. Or if you don't want to do this, you can also do this one. You can find the area of the trapezium using the formula half sum of the parallel sides into distance between them. Distance between them is CM. So you can directly get it. Anyways, you can do it. Is it clear, children?
Yes, ma'am.
Now let me just read it from here. From C. See it. From C. Draw CE. Parallel to DA. From C, draw CE parallel to DA. Understood?
Yes, ma'am. Yes, ma'am.
So, yeah, so ADCE is a parallelogram. ADCE is a parallelogram. Why? Because AD is parallel to CE. AD is parallel to CE by construction and DC is parallel to AE. DC is parallel to AE. So ADCE is a parallelogram with AD parallel to CE and DC parallel to AE such that AD is equal to, you can write it in your own words. Okay, so such that AD is equal to, how much is AD? AD is 25, DC 60. Okay, AD is 25, DC is 60. So if AD is 25, how much is CE? AD is equal to CE. AD is equal to CE. AD is equal to CE 25. And then DC is equal to AE. DC is equal to AE 60. 60. So we found all the sides of the parallelogram. Now coming to the triangle. Triangle, we already know this is 25. This is 26. Okay, we need to find this one, EB. So how much is EB or BE? EB or BE? It is the whole thing AB minus AE. AB minus AE. AB minus AE. 77 minus 16, which is 17 centimeters. Take a picture, children. Please take a picture.
Taken, ma'am.
Yeah,
Taken.
Taken, ma'am.
good. Yeah, I'm not showing you the answer. Please work it yourself, but I'll just give you an idea. I want you to do it correctly. Just give you the idea. Because this is a variation of the same question. So see here, trapezium. Oh, other side's 15, 15. So it's an isosceles trapezium. Okay. All right. A, B, C, D. A, B, C, D, find the area of a trapezium whose parallel sides are 25 and 13. So this has to be 13 and this 25. Don't make a mistake in marking that, okay? Parallel sides 25 and 13. So the longer side should be marked 25. The smaller side should be marked 13. And the other sides are 15 centimeters and 15 centimeters. That means it's an isosceles trapezium. You should draw it like this. Have I drawn it like that? Okay. It's an isosceles trapezium. The non-parallel sides are equal. Okay. All right. Okay. So 15, 15. It's an isosceles trapezium. You get that, children? You understand that you'll have to mark 25 here and 13 here because DC is shorter than AB. Okay. All right. So tell me, what will be the construction here? Through C, what should you do? Through C?
A line parallel.
Draw a line.
Yeah, draw a line parallel to which one?
AD, ma'am.
Parallel to AD. We'll mark this. So draw, we'll say CD. Okay, draw CD. Oh, not CD, CE. Draw CE parallel to AD. Okay, then we already know that DC is parallel to AE because it's parallel to AB. So what do you say about AECD? It is a
Parallelogram.
parallelogram because both the pairs of opposite sides are parallel. Now, how much is AE?
13.
13.
13 because opposite sides are equal. How much is CE?
15.
15 because not this 15, this 15. Opposite sides of the parallelogram are equal. So this is also 15. Now, how much is the remaining portion EB?
12 centimeter.
Yeah, the whole thing is 25. So 25 minus 13, this is 12. This is 12. Now we have got all the sides of the parallelogram and all the sides of the triangle also 15, 15, 12. All the sides of the triangle. So next what? Draw an altitude from C on AB or EB, whatever. You can mark it CF. So step one, you should find the area of the triangle CEB, correct?
Yes, ma'am.
Yes, ma'am.
Find the area of the triangle CEB using Heron's formula. Then use half base into height and equate the same area. So like that you can find what? You'll be able to find the length of
CF.
CF. You should first find the area of the triangle CEB using Heron's formula. And then you get an answer, right? Half base into height is equal to that answer area. Like that, when you work like that, you can find the length of CF. And what is CF? It is the height of the parallelogram. It's the height of the triangle. It's the distance between the parallel sides of the trapezium. So now that you got CF, you can directly find the area of the trapezium, half sum of the parallel sides into distance between them. But in some schools, teachers also do it like finding the area of the parallelogram and like this. So I've worked both, but I think you can go with this or whichever is comfortable for you. Yeah. Children, please take a screenshot.
Taken, ma'am.
Yeah. 1 second. Yeah. Sorry. Yeah. Take a picture, all of you.
Taken, ma'am. Taken, ma'am.
Yeah, this also. See, it may be a simple question, but it's very important. Mostly asked. It may be very simple for you, but yeah, you have to try this on your own. I'm not showing you the answer. Take a picture of the question. Work this by yourself. We'll see the answer in the next class.
Taken, ma'am.
Yeah. Oh, see this one.
I'm wondering, can you show the
Yes.
slide?
Yeah, sure, sure. Oh, no. Yeah.
Taken.
Yeah. Yes. So a kite is in the shape of a square with diagonal 32. You can see the figure here. A kite is in the shape of a square. This is the square. This is the square. A kite is in the shape of a square with diagonal 32. We know that in a square, diagonals are equal. In a square, diagonals are equal. Okay, so 32, 32. And an isosceles triangle of base 8 centimeters, isosceles triangle of base 8 centimeters and side 6. So whenever it's given base, that means it's not any of the equal sides. Base is 8 and the equal sides are 6 centimeters. Okay, is to be made of 3 different shades as shown in the figure, but we can't see the 3 different shades. You can see it marked here, 1, 2, and 3. These are 3 different regions, all right? So these 3 different regions are of 3 different shades. Region 1 is triangle ABC. Region 2 is triangle ADC. Region 3 is triangle DEF. These 3, what do you call, portions are made of different shades, different colors. The color paper used to make the kite is different for 1, 2, and 3. How much paper of each shade has been used in it? How much paper of each shade has been used in it? So the kite is in the form of a square with a isosceles triangle base. Square with isosceles triangle base. For the square, the diagonals are given. And for the isosceles triangle, we know everything, meaning all the 3 sides, 6, 6, 8. So we can easily find the area of the triangle using Heron's formula. So you can find the area of region 3 easily using Heron's formula because you know 6, 6, 8, all the 3 sides. Now we'll have to find the areas of regions 1 and 2. 1 and 2. Now we have to use the property of a square here. In a square, the diagonals are equal. That's one thing. In a square, okay, diagonals are equal. Diagonals are equal. Then diagonals bisect each other. Diagonals bisect each other at right angles. Bisect each other at right angles. At right angles. All right. So diagonals are equal and they bisect each other at right angles. So how do we apply this property here? So see here, this one will be 16. This is 16. This is 16. This is 16. This is 16. And like this. Am I right, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Everywhere it's 90. Everywhere it's 90. Everywhere. Like in a rhombus. In a rhombus, diagonals are unequal. In a rhombus, diagonals are unequal. The similarity between a rhombus and a square is that in a rhombus, in both rhombus and square, all the sides are equal. All sides are equal. Square, all sides are equal. Rhombus, all sides are equal. The difference is that in a rhombus, diagonals are unequal. They bisect at right angles, but the diagonals are unequal. In a square, diagonals are equal and they bisect at right angles. Diagonals are equal. Rhombus, diagonals are unequal. Okay. Is this understood, children?
Yes, ma'am.
Okay. Now, the area of region 1, area of region 1 is equal to half base into height. Half into base AC into height OB. Am I right? Region 1 is the triangle ABC. Region 1 is the triangle ABC. Base is AC and height is BO or OB. Correct?
Yes, ma'am.
Yes, ma'am.
So half into AC is 32, not 16. AC is 32. AC diagonal 32 into OB 16. Correct?
Yes, ma'am.
Yes.
Raja, are you there?
Yes, ma'am.
Okay, okay. Okay. So area of region 2. Area of region 2. Raja, which is region 2? Name the triangle.
BOC.
A?
AOD.
No, I knew. That's why I asked you. It's not AOD. Okay, name the triangle in region 1, which is marked region 1. Name the triangle which is marked region 1. Okay, let me clear the slide for you. Anybody wants to take a screenshot can take it now. I'm going to clear the slide. If you want the slide with this information, take a screenshot now. Yeah. Okay. Yes, Raja. Tell me which is region 1, Raja.
BOC, ma'am.
Oh, see, just because it is marked here, okay, if this is region 1 and this is region 2 and this is region 3, then is this the kite? Is only this portion a kite?
No, ma'am.
So they are telling that, see, look at the question. How much paper of each shade has been used to make the kite? So you must understand that when just because one is marked here, it doesn't mean that only this is one. Now tell me which is region 1.
Ma'am, BAC.
Yeah, louder. You're right, louder.
Triangle BAC, ma'am.
Or ABC. Okay, is equal to half into what is the base?
AC, ma'am.
Height.
OB, ma'am.
What's the base? What is the value of AC?
32 centimeters.
OB?
32. Sorry, ma'am. 16.
16. Which is the other triangle? Region 2?
Ma'am, ADC. Triangle ADC.
Is equal to half into base?
32 centimeters.
No. Base. Like this I want.
Oh, AC.
Into height?
Into height OD.
Very good. Half into AC is
32.
OD?
16.
Which is region 3? Triangle?
Triangle EFD or EDF.
Okay. Or DEF. Correct. Anything. What is a special name you can give to the triangle? It is an
Isosceles triangle.
isosceles triangle. And how will you find the area? Using?
Using Heron's form.
Tell me the formula, Heron's formula. Root of?
Root of S into S minus A, S minus B, S minus A into S minus B into S minus C.
Okay, very good. And what does S stand for?
Semi-perimeter.
Semi-perimeter means what?
Half of the perimeter.
Half of the perimeter. Okay, and what about A, B, C? What do they stand for? A, B, and C?
Sides of the triangle.
Very good. Sides of the triangle. All right. So good. So like this, children, you can find the, so now they're not asking you to find the area of the paper used in the kite. They want you to find the area of region 1 separately, 2 separately, 3 separately. And we found here. Understand, children?
Yes, ma'am. Yes, ma'am.
Yeah, take a picture.
Taken, ma'am.
Very good.
Taken, ma'am.
Valid.
Taken, ma'am.
Yeah, you can, if you want, repeat, area of region 2. If you want, you can repeat is half into base, like what I told you now, base AC into height OD. So that is half into 32 into, you can repeat that. 16, you can repeat this. I've just written the same because it's the same, no, they're identical triangles. So I've not worked, I've just written the same answer here, 256. You can work it like I explained earlier here. Done, children?
Yes, sir. Yes.
Yeah. Yeah, this is simple. I have nothing to explain. See here, an umbrella is made by stitching 10 triangular pieces of cloth of 2 different colors. An umbrella is made by stitching 10 triangular. Yeah, if you spread open an umbrella, you can see, triangular portions. Okay, 10 triangular pieces of cloth of 2 different colors. So maybe like a blue and green alternating, blue, green, blue, green, blue, green alternating. Totally, there'll be 10 triangles, 10 pieces, 5 blue triangular pieces, 5 green triangular pieces. So 2 different colors, each piece measuring 20, 50, 50. How much cloth of each color is required for the umbrella? Each color. So how much cloth for green, how much cloth for blue, you should find separately. You should not find the total area of the cloth in the umbrella. Answer the question. How much cloth of each color is required for the umbrella? Okay. So I've worked the area of one triangular piece. Okay, one triangular piece. And that is the area of cloth of each color needed. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah. Yeah, take a picture, children. Please concentrate on the calculation part. Do not blindly copy. Please concentrate on the calculation part.
Taken, ma'am.
Yeah. Yeah. So this is similar to the earlier one. A floral design. Okay. A floral design. Floral meaning a flower-like design. Floral design meaning a flower-like design. What is flora and fauna?
Animals and plants.
Animals and plants or plants and animals?
Plants and animals.
Plants and animals. Yeah. So like flora and fauna, floral, meaning of flower. Flower-like design. Flower-like design, floral. Okay, so you can see this. In olden days, like if you see the houses in the villages, the hall, in the middle of the hall, the, 1 second. Yeah. So mostly in the hall, in the middlemost portion of the hall, the tiles, used will show a floral design like this. Not in every other house, but we do get to see this. Okay. So this is very common in houses and villages. Mostly in the hall, the middle portion, or maybe here and there, you can see your tiles arranged to make a flower-like design. Okay, a floral design on a floor. So floral design is made up of 16 tiles, which are triangular in shape. So this is not one single tile, This is not one single tile. This full thing is not one. Don't think that this is one tile and they just come and keep it in the hall like that. No, these are the tiles. See, this is one tile. This is One tile. Oh my God, I'm not able to go on it. One side of the triangle. Second side of the triangle, sorry. And there's a third side of the triangle. Let me take some other piece. Okay, let me take this triangular piece here. One side, second side, third side. So two triangles put together. So now there's another triangular tile. One, second side, third side. These two triangular pieces are kept together, and that's how you get one petal. These are the petals of the flower. This is a petal. This is the petal. So how many petals are there? 1, 2, 3, 4, 5, 6, 7, 8 petals. And these, how are the 8 petals formed? Using 16 tiles. These are petals of the flower. This is the flower-like design. And this flower has 8 petals. And one petal is made of 2 triangular tiles. One petal, or each petal is made of 2 triangular tiles. When you place, all these are identical tiles. These are all identical tiles. So when you place them in a particular way like this, you get a petal. And these 8 petals together form the triangle, floral design. And what are the sides of the triangle? Triangular tile, 9 centimeter, 28 centimeter, 35 centimeter. One triangle. The other triangle again, 9 centimeter, 28 centimeter, 35 centimeter. So you should keep the 35 centimeters coinciding like this. Then you get a petal. Question clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Now,
Yes.
the question is, so you can find the area of one triangular tile. You can find the area of one triangular tile. Like that, 16 tiles are used. See here, triangular tiles, nothing to get confused. See here, this is one triangular tile. One, this is the second triangular tile. 3, 4, 5, 6. Like that, when you count, you'll get 16. One petal, this is one petal. This is one petal. It has 2 triangular tiles. 8 petals, 16 triangular tiles. So find the cost of polishing the tiles at the rate of rupees. Oh, sorry. Find the cost of polishing the tiles at the rate of 50 paise per centimeter square. So nothing, just find the area and multiply with 50 by 100. If you just multiply by 50, you will get the the cost in paise. Divide by 100 to find the cost in rupees, or you can directly multiply by 50 by 100. Because what is 50 paise? It's equal to rupees 50 by 100. When you divide by 100, it's converted to rupees. If you multiply the area by 50 paise, you will get the answer in paise. Then you should divide by 100 to convert it to rupees. Or you can directly multiply by 50 by 100 rupees. So the answer will be in rupees. 50 by 100 is nothing but 1 by 2. 1 by 2. Yeah, take a picture, children.
Taken, ma'am.
Yeah. All of you?
Taken, ma'am. Taken, ma'am.
All right. All right, children, I'm not winding up early. I want you all to complete these sums and share the pictures with me by today. Maybe you can write the question later. You can write the question and copy the diagram later. I'm not asking you to do that. If you have time, you please do that now itself. If you have time, do it now itself. Otherwise, leave some space for the question. Leave sufficient place for the question. You can write it later. Okay, and work the answers. Work the answers and share the pictures with me today. All of you today by 10 p.m. All of you today by 10 p.m. All right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. Raja and Tanishka, yes or no?
Yes, ma'am.
Tanishka?
Yes, ma'am.
All right, children. All right, children. That's it for today's session. Thank you so much. You may leave the call.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Ma'am,
Thank you. Yeah. 1 minute. I'll just stop the recording. Just a minute.